Welcome to Narayana Online Digital Classes. I am going to present 25th Session 2 Physics paper in front of you. I am myself Raghavendra. Presenting in front of you question number 1. A solid sphere as shown is rolling without slipping. Find maximum length travelled on an inclined plane. It is a problem from your rotatory motion. Body is rolling. It will have translational kinetic energy plus rotational kinetic energy. You can use principle of conservation of energy. First, you take how much kinetic energy it have. Translational half mv squared, rotational half I omega s squared, and this will be equal to mgh. They are asking you find maximum length travelled. Suppose if it is travelling h, then this side h will become L sine theta. So this will be equal to mgl sine theta. Now half mv squared, moment of inertia you check, it is a solid sphere. So it will be half 2 by 5 mr squared omega squared means v squared mgl sine theta. So how much you are getting? You are getting 5, 2 and 5 mv squared take out. It will become 10, 5 plus 2. This is equal to mgl sine theta. M is cancelled. They are asking you L. L will be equal to 7v squared by 10 g sine theta. Okay, no? So answer is number 1. Simple. You have used conservation of energy. You have equated kinetic energy, total kinetic energy, translational plus rotational, and this is equal to potential energy. In this, so many variants is possible. Here you have taken even a rolling on inclined plane. It may be possible that it will be completely frictionless. In that situation, you will have to equate translational kinetic energy equal to potential energy. Here they have not mentioned, so we have assumed that it has rolled on inclined plane. Friction is sufficient enough for body to roll over the inclined plane, and you are getting in that way answer 7v squared by 10g sine theta. Let us move to simple question, moderate one. Let us move to next question. Question number 2. In an amplitude modulated wave, message wave frequency FM, carrier wave frequency FC, find out wavelength of amplitude modulated wave. They are asking you simple wavelength. You know that wavelength will be equal to velocity of electromagnetic wave divided by frequency of carrier wave. So C by FC. Very, very simple. Just the definition of wavelength you have considered. Your answer is number 1, C by FC. Move to question number 3 now. A unit particle is moving in a circle of radius r such that its projection on diameter executes SHM. They have given you in time 0.1 second, angular displacement is 30 degree. You can get angular velocity of the particle, omega, angular displacement by time. So 30 degree means pi by 6 and time is 0.1. So it is pi by 0.6 radian per second. They are asking you find force acting on the particle at position B. Here only one force is acting, that's your centripetal force. So force they are telling you to find out, F, this is mr omega s squared. Now check what quantity, unit mass, it is 1. We'll have to go for radius r 0.36 meter they had given you, omega s squared, this will be equal to pi s squared by, okay, 0.6 s squared is 0.36. These two cancelled, you are getting pi s squared Newton, and pi s squared is 3.14 s squared, nearly 9.7 Newton. So your answer for this is number 1. Undoubtedly, they must mention the unit. They have not mentioned. It will be in Newton. Answer will be 9.7 Newton. Did you understand it? Very simple. You have got omega, and after finding omega, F equal to mr omega s squared you have used. Now, let us move to question number 4. In front of you, 4 is there. Sunlight is diffracted through a circular aperture of diameter 0.1 micrometer. So, diameter is slightly increased. If you take like that, if I take Fraunhofer class of diffraction from a single slit, then sin theta is lambda by A. If you will take resolving power, then it will become 1.22 lambda by A. By any way you take, it is inversely proportional to, theta is inversely proportional to either width of the slit, or if you take a here, so you take D as diameter, it will become inversely proportional to diameter. So when you are increasing the diameter, what will happen to size? Size of, see, when D increases, theta decreases. It means that size of circular fringe will decrease. Clear, no? Size of circular fringe will decrease. When size will decrease, automatically intensity will increase. Answer for question number 4 will be number 2, that theta inversely proportional to diameter. Diameter you have increased, so size of circular fringe will decrease. When size of fringe is decreasing, intensity is increasing. Let us move now to question number 5 now. I am now on 5. Proton and electron are moving along circular path with same speed. So V is same. Ratio of de Broglie wavelength, damn simple. If you remember expression for de Broglie wavelength, lambda equal to h by mv. Now, ratio of de Broglie wavelength, lambda electron, so here you see this is constant, this is same, so lambda is proportional to 1 by m. Now they are asking you lambda E by lambda P, right now. So this will be equal to mass of proton by mass of electron. Mass of proton already they had given you 1836 times, so 1836 is to 1. So ratio of de Broglie wavelength for lambda electron and lambda proton will be equal to 1836, 1836 is to 1. Simple formula for de Broglie wavelength, no need to change even P. Most of the cases where problems are related to de Broglie wavelength, we are using kinetic energy, okay, no, or accelerating potential. Here no need, straight h by p you have used. Let us now move to question number 6. It is slightly tricky but easy. Find out dimensions of 1 by 4 pi epsilon naught E square by SC. You know that from Coulomb's law, F equal to 1 by 4 pi epsilon naught Q square is E square by R square. If I take dimension 1 by 4 pi epsilon naught E square, then this will be dimensional formula for FR square. Clear to you? Now, you are going for HC. You know that energy is SC by lambda. So, dimensional formula for HC will be for E into lambda, and E is FR and lambda again R, this is FR squared. So, if you will take dimensional formula for 1 by 4 pi epsilon naught E square by HC, you are getting FR squared by FR squared, and they are cancelling each other. So, this quantity will not have any dimension. It is a dimensionless quantity. So, your answer will be number 4. Simple. If you will try to substitute the value of dimensions for epsilon naught, E, R, H, C, it will take lot of time. But if you take just Coulomb's law and you are using energy for SC by lambda, you can solve the problem within few minutes. Okay, now let us move now to next question, question number 7. In a given AC circuit, series circuit, it has R, L and C. It is known that if L alone is removed or if C alone is removed, phase difference between current and voltage, it is not changing. It remains 45 degree. It directly means that it is series resonant circuit now. If you take like that, I am taking phasor diagram. If it is I, here it is VR, here it is VL, here it is VC, this angle is 45 degree or this angle is 45 degree, it directly means that VL equal to VC. It is purely a series resonant circuit. So, they are asking you IRMS. You know that in series resonant circuit, your impedance is equal to resistance. So, IRMS will be equal to Vrms by resistance. They have given you 220 volt and it is 110 ohm. So, you are getting IRMS as 2 ampere. Answer for this is number 1. Very, very simple question. Let us move now to next question, question number 8. Statement: rotational kinetic energy of a gas molecule follows Maxwell speed distribution curve. You know that Maxwell speed distribution, that graph is plotted in between number of molecules and the velocity ranges. So, guaranteed statement 1 is completely a wrong statement. If you go for statement 2, you have rotational kinetic energy and translational kinetic energy of a diatomic gas molecule is same. If you take degree of freedom for translational, for a diatomic molecule, it is 3. So, it will become 3 by 2 RT, and rotational kinetic energy 2. The 2 by 2 kT, these two are not equal. So, translational kinetic energy of one diatomic gas molecule 3 by 2 kT and rotational will be 2 by 2 kT. These two are not equal. So, statement 2 is wrong, statement 1 is wrong. So, your answer will be number 3. Undoubtedly, these problems are based on memory. Whatever children have told, based on that we have taken questions. Certainly some mistakes may be there. Later on, when correct question paper will come, again we will come in front of you with correct questions and their keys and solutions. At present, only on memory-based questions we are going on telling you. So for this particular question, statement 1 is wrong and statement 2 is also wrong. Let us move now to next question. I am now question number 9. If an electron of hydrogen atom jumps from 2 to 1, find wavelength of released photon. You know energy 13.6, 3.4, 1.51, 0.85, 0.54, you have mugged up. Okay, no? If electron is jumping from second to first, difference of energy comes out in the form of electromagnetic, if you are considering photon. So you have minus 3.4 minus of minus 13.6, okay, no, this much electron volt, this much energy is coming out. This is, you can see that 10.2 electron volt energy is coming out. Now wavelength, shortcut method you have, lambda in here answer is in nanometer, nanometer is 1240 by 10.2 in electron volt. So 1240 by 10.2, when you will be dividing, it will be nearly 121.5 nanometer. So for question number 9, answer will be 1. Simple, easy question. Simply you have taken difference of energy and you have used formula 1240 by 10.2. One thing, if you want in angstrom, you must take here 12400 by energy in electron volt. Let us move now to next question. I am now on question number 10. In photoelectric effect of a certain metal, stopping potential, first they have given you V1 0.71 volt if the wavelength of radiation is lambda 1 491 nanometer. Now stopping potential becomes V2 1.43 volt if the wavelength of incident radiation is, they are asking you lambda 2. Direct problem on Einsteinian photoelectric equation. You know kinetic energy max. This is equal to energy of incident photon Sc by lambda minus W naught, and this is your EVS. Clear to you? So now you check here. First they had given you 491. So Hc by, I am not changing the unit, 491 minus W naught, this is equal to E into 0.71. Undoubtedly, if you remove this 0.71, electron volt will be there. From this, you can check that W naught is there. So W naught you can take that side. Second one will be Hc by lambda 2 lambda minus W naught will be equal to E into 1.43. Clear? Now you want lambda. So for cancelling this, from this equation you can have Sc by 491 0.71 electron volt plus W naught, and here it is Sc by lambda, you will have 1.43 electron volt plus W naught. You just take the ratio, okay, Sc cancelled, you will have lambda by 491. You have just taken the ratio. Lambda by 491 0.71 plus W naught by 1.43 plus W naught. Now, just solve this. You will be getting the answer 3 lambda. You will be getting 382 nanometer. Answer will be 382 nanometer. Let us move now to question number 11. Two particles having masses 4 gram and 16 gram. If kinetic energy of both the particles are equal, ratio of their momenta they are asking you. Kinetic energy, you know, this is P squared by 2m. They are telling you kinetic energy of both the particles are equal, means it is constant. So P squared directly proportional to m. They are asking you ratio of linear momenta. So P is proportional to root m. So P1 by P2 will be under root m1 by m2. Now, they have given you m1 4 and m2 16. So this is 4 by 16, 1 by 4, 1 by 2. Your answer will be number 2. Simple. Kinetic energy equal to P squared by 2m. Every child knows. I hope that you people also have done well. Overall physics paper, if you see, it is just simple paper. Let us move now to next question. Question number 12. An electron enters in a capacitor making an angle alpha with one plane having kinetic energy K1 and comes out with kinetic energy K2 making an angle beta with other plane. Okay, now find ratio of K1 and K2. It is entering, electron is entering in a capacitor. If this is my capacitor, one plate will be positive, other plate will be negative. If you take lines of forces, it will be like this. Okay, no? I am taking at any point, electron is entering here. Okay, no? They have told you it is entering at an angle alpha with one plane having kinetic energy. Let us take angle is alpha and kinetic energy here is K1. And let us suppose it is going like this and it is emerging out here with kinetic energy K2 and making an angle beta with this. You can see that in horizontal direction, no force is acting. Whatever force will act, it will act in vertically downward direction. So component of velocity in horizontal direction will always remain constant. If I take here V1 and here if I take velocity V2, so V1 cos alpha, this must be equal to V2 cos beta. Am I right? So V1 by V2 will become cos beta by cos alpha. So V1 squared by V2 squared will be equal to cos squared beta by cos squared alpha. If I multiply it by half m in numerator and in denominator, it will become kinetic energy. So and they are asking you ratio of kinetic energy. So K1 by K2, you have multiplied by half m, they are cancelling. So K1 by K2 is nothing but V1 squared by V2 squared. This will be equal to cos squared beta by cos squared alpha. Your answer will be number 1. Check. Very simple. you have just considered that in horizontal direction, no force is acting, there is no acceleration. So velocity in horizontal direction you have taken constant, and within 1 minute you are going to get the answer. Let us now move to question number 13 now. A gas follows Pv power half constant. Okay, no? So you have Pv half constant, and they are asking you ratio of T2 and T1 when V2 is 2V1. You know that PV equal to nRT. So P is directly proportional. Check here. P is proportional to, here I am taking P, I will change. So P is nRT by V. nRT by V. Substitute it here. So you are getting nRT by V, and V half, it is constant. So TV half is constant. They are asking you T2 by T1. So T is proportional to root V. They are asking you T2 by T1. So T2 by T1 under root V2 by V1. They have given you V2 as 2V1. So it is equal to 2V1 by V1. V1 is cancelled. It is root 2 is to 1. So answer number 2, root 2 is to 1. Simple. Pv power half constant. You have substituted the value of P, and then you have developed a relation between V and T, and directly you are substituting whatever value they have supplied to you, V2 equal to 2V1. Simple, no? Let us move now to next question. Now, question number 14. For a given logic gate, which truth table is right? First, you must check all these. This is not, this is not, this is and this one is not. You must have to, you'll have to identify all the symbols. So finally, what is Y? So here if I go, it is A naught, directly B, okay, and here you have, check, A, B naught, you have B naught, and this is NOR, plus this is NOR, this is your Y. Clear, no? Now you will have to check each one. I am taking 0 and 0. If you take this, if I take A0, B0, right now, so this will become A0, 0 naught, 1, and this is 0. So you are getting what? 0. A naught B, you are getting 0. And if I take A B naught, so this is 0, 0 naught is 1, this is 0. So 0 plus 0, 0, naught, this will be 1. So this statement is right. A0, B0, Y you are getting 1. Now you go for 1, 0. Now I am taking A1 and B0. Then what will be there? A naught B will be 1, naught, 0. And already B is 0. So you are getting 0. And I want AB naught. AB naught. Okay. The A is 1, B0, you are taking B0, B0 naught is 1, am I right? So you are getting 1, 0 plus 1, 1 and not 0. So 1, 0, 0. Like this, you check for 0 and 1, you will be certainly getting 0, 1 and 1, you will be getting 1. Your answer is number 1. The technique you must learn. First, identify all the symbols. Whatever operations you will have to do. For here, it's not, and it is not. So complete Y is A naught B plus AB naught and overall naught. Every time whatever in truth table they had given you, you'll have to substitute the value and you'll have to check for only 4. 0, 0, 1, 0, 0, 1, 1, 1. For 2 I have shown you here. So key for this is 1. Let us move now to next question. So I am now on question number 15. Match the following. In all these examinations, the first time we are finding that in mains, they have asked you matching question. Transformer. Already you know transformer, what is the work of transformer? If you have AC, either you can increase the voltage, step up, or you can decrease the voltage, step down. And it will happen only for AC, it is not possible for DC. So what is happening? National grid system of any country, they have fed only in AC. The reason is only because transformer will work for AC and which can increase or decrease AC voltage. So for A, answer will be Q. Rectifier, already you know, it will convert AC into DC. So B, answer will be P. Filter circuit, in any signal, you can remove AC component or DC component. So whatever ripple is present, you can remove. So for this will be R. Stabilizer, already you know, whenever you want output to remain constant, you are using, stabilizer. In India, it is too much needed. Here, too much voltage fluctuation is there. Maybe your fridge, AC, anything you take for safeguard the electrical or electronic devices, we are requiring a stabilizer. So for D, answer will be S. A, Q, B, P, C, R, D, S. Check. A, Q, B, P, C, R, D, S. Answer is 1. So for 15, answer will be 1. Let us move now to next question. Question number 16 now. Time period of oscillation. Verbally you can solve this. You can easily see that this is parallel combination of two springs. If you don't want to take parallel combination, simply you can take K1 plus K2. 2K, it will become 4K. Clear to you? Time period is T equal to 2 pi under root M by K equivalent. K equivalent is 2K plus 2K, 4K, 2 pi under root M by 4K. Answer. If you will tell, no sir, from basics we want to learn, no problem, move it a bit by distance. I am taking by distance x. So what will happen? It will be stretched by distance. Let us take it is K1, it is K2. Then this spring is stretched by K. The restoring force will act in this direction towards my left hand in this direction, K1x. This is first restoring force. And at the same time, this spring will be compressed by same distance x. Again, one restoring force will act, and that restoring force will act in the same direction. This will become K2x. net restoring force acting on the block will become K1x plus K2x. This will become m omega s square x is cancelled, omega s square will be K1 plus K2 by m. Omega s square is 4 pi s square by t s square. T will become 2 pi under root m by K1 plus K2. If you have forgotten the formula for series and parallel combination of springs, then you can easily derive it. You are getting now 2 pi under root m by 4k, because K1 and K2 they had given you 2k and 2k. So answer here will be number 2. I hope you have understood clearly, and every time we are finding that this combination of spring-based questions are coming, maybe mains, maybe advanced, everywhere problem based on combination of springs have come. So take extra attention for these kind of problems. Now let us move to next question, question number 17. A particle starts performing SHM on a smooth horizontal plane and it is released from x equal to a by 2 and it is moving in negative x direction, then they are asking you phase difference. If you take circle of reference, so I am drawing a circle of reference. This is amplitude A, this point is a by 2 and it is moving in negative x direction. If you take negative x direction, then rotating factor will be here P. So if you take phase difference, then this angle is phi. Clear to you? Now it is a by 2. 1 by 2, 30 degree sine theta. So this angle is 30 degree. Directly from circle of reference you can say that this angle will be 150 degree. Am I right now? Total 180. So 150 degree. So you can check here 30 into 5, 150 degree. Your phase difference will become 5 pi by 6. Answer may be 30 degree also. If they will put here, it is moving in positive x direction. If it will be moving in positive x direction, then rotating factor will come here and then phase will become phi, simply pi by 6. Because it is moving in negative x direction, so your phase difference is this much. You can mark 0, x, y, x dash, y dash. Very, very simple problem. The children who are knowing circle of reference, they can solve it just in 10 seconds or 20 seconds. No need to draw the diagram also. Simply by seeing a by 2 and minus, he can take the answer. Let us move now to next question, 18. For an extrinsic semiconductor, if doping concentration is increased, then what happens to Fermi level? Everywhere they have asked you Fermi level. You know that Fermi level will be telling you probability of occupation of a particular value of energy by any electron. If you have pure intrinsic semiconductor, if it is highest level of valence band and this is lowest level of conduction band, then for pure semiconductor, it is completely in the middle of band gap. If it is n-type semiconductor, it is nearer to valence band. If it is p-type semiconductor, it is nearer to conduction band. If you are increasing the doping concentration you will increase, then what will happen? They have given you for n-type and p-type Fermi level will increase. No, For n-type Fermi level will increase and for p-type Fermi level will decrease. For n-type Fermi level will decrease, for p-type Fermi level will increase. It's not like that. If doping you are increasing, number of electrons you are increasing, so Fermi level will shift more nearer to valence band for n-type semiconductor, and for p-type semiconductor, it will move more nearer to conduction band. For pure semiconductor, it is completely at the middle of band gap. For n-type semiconductor, it is nearer to valence band, it will go more nearer to valence band. For p-type, it will move more nearer to conduction band. So in these four, I feel that more accurate answer will be for n-type Fermi level will increase and for p-type Fermi level will decrease. Clear to you? Now, let us move to next question, question number 19. If tension is increased by 4% in vibrating string, speed they are asking you, speed of transverse wave, C under rho T by mu, C proportional to rho T. They are asking you percentage change in velocity, no? If you take percentage change, it will become dC by C into 100. This will become K root T. So half dt by T into 100. Am I right? No. The percentage change in speed, they had given you tension 4%. So it will be 4 by 2. Directly it will become K. Remove now percentage change you are talking about. So 4 by 2, answer will become directly 2%. If they will ask here for mu, then it will be just reverse, but again answer will be only half times then. Here 4 by 2, answer will be 2%. If tension you are increasing by 4%, speed of transverse wave, okay, no, will increase by 2%. Let us move now to next question, question number 20. P cross Q equal to Q cross P, these two will be equal only when either P will be 0 or Q will be 0, or you know that cross product of two vector will be anti-commutative. So only two possibilities you have, either P should be 0 or Q should be 0, or angle between these two should be 0 or 180 degree. So here directly conceptual question we will be taking for answer 180 degree. Okay, no, they have taken 360 degree. Usually we never take angle between any two vector as 360 degree. Usually we are taking in between 0 and 180. So answer here, if P and Q you are not taking as 0, then angle between these two we will take as 180 degree. Now let us move to next question number 21. A satellite is projected from surface of Earth so that it can attain 10 hour height from surface of Earth. Its speed at surface of Earth is directly principle of conservation of energy you use. You are projecting it from surface of Earth. If I take Earth, this is R, and you want to take it to 10 R, mass of Earth m, mass of particle I am taking a small m, satellite mass I am taking a small m. So you want that from surface of Earth it can attain 10 hour height. So when it will attain 10 hour height, how much potential energy satellite will have? It will have minus g m m by 10 plus 1, 11 hour. Clear to you? And now You take its total energy on the surface of Earth. How much potential energy it has? Minus Gmm by R plus, they are telling you, projected from surface of Earth, and they are asking you speed at surface of Earth. If I take a speed v, the plus half mv square, this will be equal to minus Gmm by 11R. So how much I am going to get? Half mv squared minus Gmm by 11R plus Gmm by R. Clear to you? So m I remove, v squared by 2, here I have taken out Gm, even you can take R out, so minus 1 by 11 plus 1, so Gm by R, it is 11 minus 1 plus 11 here, you will have 10 by 11 Gm by R, this is V square, 2 you put here. So V will be how much? V will be under root 2 Gm by R under root 10 by 11. This is nothing but V escape under root 10 by 11. They are asking you V escape into x by 11. So I feel that the value of x will be 10. So answer for number 21, x will be equal to 10. Did you understand this? Simple conservation of energy you have used. You have taken total energy, potential plus kinetic on the surface of Earth for the satellite, and at an altitude of 10R, you have taken only potential energy and you have equated these two. Answer is ready for you. Now, let me move to next question, question number 22 now. Yeah, there is an electric circuit now. Okay, 6 ampere current is coming, point P and R. See here, 4 ohm and 2 ohm, they are in parallel. V equal to IR. V is constant in between P and R if you take. Here I1, I2 if you will be taking. So I1 R1 will be equal to I2 R2. So I1 by I2, R2 by, verbally I can do, but I am showing you. Okay, no? So I1 by I2 will be equal to R2 by R1. So you see here, R2, 2, R1, 4, 1 by 2. So I1 will be equal to I2 by 2. I1 plus I2, they had given you 6 ampere. Am I right? So I2 is 2 I1. So it will become 3 I1 as 6 ampere. I1 will become 2 ampere. So they have asked you find I1, simple current distribution in parallel combination of resistors. They had asked you, in 1 minute you are going to get. I have shown you these steps, no need, directly you can take 6 ampere current is coming, ratio of resistance is 2:1, so current ratio will be 1:2, 1:2, 3x 6 ampere, x 2 ampere, verbally you can say the answer as 2 ampere. Now, let us move to Next question. So this one was, now question number 22, it was question number 23 now. W by Carnot cycle, Carnot engine. Okay, from additional chapters also they are going on giving you many questions. W by Q in 1 by 4, 1 minus, they had taken sink temperature is decreased, find out source temperature, 1 minus T2 by T1. So T2 by T1, 1 minus 1 by 4 is 3 by 4, right? Now, sink temperature is decreased by 52 degree, then it becomes half. So half equal to 1 minus T2 minus 52 by T1. So you are getting T2 minus 52 by T1. This is in left hand side, half in that. Right hand side it is half. So T2 by T1 minus 52 by T1, this is half. T2 by T1 is 3 by 4. So or you are taking 3 by 4 minus 52 by T1 is half. So I am getting 52 by T1 as 3 by 4 minus half, that is 1 by 4. So T1 will become 52 into 4 degrees centigrade, 208 degrees centigrade. Your answer will become 208 degrees centigrade, and that will be the temperature of source. So question number 23, direct formula based question it is. Okay, no, 1 minus T2 by T1, and answer is ready as 208 degrees centigrade. Now, let me move to question number 24. A particle is dropped from the top of a tower. So this is a tower. You have dropped a particle from here. It has traveled a distance of 5 meters. S equal to half GT squared. So half G, let us take 10 T squared. This one they have given you 5. 5 T squared. T becomes 1 second. Means in 1 second, okay, it has traveled a distance of 5 meters. Another particle is dropped from a distance of 25 meters below the top of a tower. So it has traveled a distance of 5 meters. So this distance will become relative displacement will be 20 meters because this distance is 25 meters. Distance of 25 meters below the top of tower, and both of them reach the bottom of tower simultaneously. So they will be catching each other in how much time? So distance, relative distance, S relative by V relative if you take, this is 20, and how much velocity it is getting? V equal to U plus AT, GT. So 10 into 1, so this will become 10 meters per second, 20 by 10, 2 seconds. So it will just take 2 seconds and both of them will reach the bottom of tower. So total time of journey, that will become 3 seconds for first particle. In 3 seconds, how much distance it is traveling? Half G T squared is 9. It is becoming 45 meters. So height of tower is simply equal to 45 meters. I have told many times, whenever kinematics questions are coming, simply based on fundamental equations of kinematics, you can solve any problem. V equal to U plus AT, S equal to UT plus half AT squared, V squared equal to U squared plus 2AS, just use fundamental formulae. No further preparation is needed for solving the problem. Okay, now this will be the shortest technique. If you simply want to use S equal to ut plus half ATA squared, then also you can solve the problem 10-20 seconds extra you will be taking. Your answer, they have asked you height of tower, your answer is 45 meter. Clear to you? Now, let us move to next question. I am now on question number 25. For a X-ray, if its wavelength is 10 angstrom lambda, 10 angstrom, mass of a particle having same energy and same wavelength, your energy is same and lambda is same as X-ray and same wavelength as X-ray, mass of a particle having same energy and same wavelength as X-ray is xh by 3. They are asking you x, means they are asking you mass of the particle. Okay, no? So if you go for energy of X-ray, how much you are getting energy of X-ray? If you are going for energy, okay, no, the energy will be hc by lambda. This is the energy of X-ray photon. And if you go for this side, the Ps square by 2m, Ps square by 2m for the particle, Ps square is h square by lambda square 2m. 1h is cancelled, 1 lambda is cancelled. I am interested in here is c h by 2 lambda m. I want m equal to h by 2c lambda. Now, h, if you are taking x, h by 3, clear, no? So, they have given you all the values, you will have to substitute the value. Lambda is also they have told you same, clear? I have taken energy same here already. So, C value you will have to substitute H, okay, no? And here it is 2C. C you will be taking here lambda, they have not told you in which unit they are telling. So, I will be taking 3 10 to the power 8 and lambda, okay, no? 10 angstrom, 10 to the power minus 10 if you are taking. So, this will become h by, okay, 10 to the power minus 9. So, 6, it will become 0.6. So, you are getting 0.6, h by 0.6. So, 3 to 6, I am having x h by 3 h by 0.6. So, if you take that x, h is cancelled, x will become 3 by 0.6. I am getting 30 by 6, 5. The value of x will become 5. Simple. You have equated, they have told you energy same. You have equated energy of X-ray photon to energy of the particle and substituted the value of P as h by lambda. Your answer is ready. Answer is 5 for x. Clear to you? Now, let us move to next question. We have two conducting charged particle of negligible volume. This is very important line. If you have two charged particle, if they are particle and you are making them in contact with each other, then they will equally share the charge. But if they will have volume, then the sharing of charge will depend upon potential. You will have to equate the potential, problem will be slightly difficult. Here, they will equally share the charge. 2.1 and minus 0.1. Add these two, you are getting 2 nanocoulomb, equally distribute 1 nanocoulomb and 1 nanocoulomb. They are asking you force of interaction. You will be using Coulomb's law. Coulomb's law, F 1 by 4 pi epsilon naught Q1 Q2 by R square, 9 10 to the power 9, 1 and 1 nanocoulomb it is. Okay, no? So it is 1 10 to the power minus 18.5 meter. Okay, no? If you are taking 0.5 meter, it will become 0.25. Okay, so this is 9 10 to the power minus 9, 0.25 is 1 by 4, 4 I will take up, you are getting 36, 10 to the power minus 9 Newton. They are asking you value of x, x will be equal to 36. So answer for x as 36. Simple Coulomb's law you have used. Important point is only one, that negligible volume. If they will have volume, then you cannot equate the charges. They cannot equally share the charge. Then sharing of charge will take place depending upon that equal potential. Clear to you? Here the problem was very simple. Answer is 36. I hope that my all students will do very well in this type of paper. Now, these are memory-based questions, beta. Okay, no? So only these many questions, whatever students have narrated to us, okay, we have explained to you. When really question paper will come, we will explain each and every question and we will give you correct questions with the correct solution. For time being, I am keeping till here. Again, next question paper will come. I will be coming in front of you to explain that paper. For now, thank you to all of you, and those students will be appearing, okay, on 26th morning or evening session. For them, I am good wishing to all my children. They will do very well in physics paper, I am assured. Thank you to all of you.